So, all good. I guess it's time to start with the presentation. So I'm Cyril Gambini. I'm a CLA, CTA also, and I work for Neosoft Technologies. Neosoft Technologies is an integrator, and we are based, system integrator, and we are based in Montreal, Quebec, Canada. So the purpose of the presentation here is about using the DQMH with TestStand and see if there are some things to focus on and to keep in mind when using the DQMH with testing. During the presentation, if you have any question, do not hesitate to post them to the chat. Vincent Carpentier is right next to me and will be able to read the chat, interrupt me if necessary. Otherwise, I will try to take a look at the chat at the end of the presentation and answer your questions. For those who just joined, there is two questions in the poll section. So you can maybe take a look at it and answer so I can roughly see the audience here, if you're familiar with the DQMH and familiar with TestStand. And I can see that a lot of you are already familiar with the DQMH and they use it every day as soon as they wake up. So that's pretty good. So let's start. And here we are. So here is the agenda. I will do a quick introduction to TestStand in case of some of you don't know what TestStand is. And then I will go through some few steps to describe what traditional TestStand programming is. So we'll see how we usually use LabVIEW steps, for example, to create a sequence. And then I will try to briefly talk about why we could use the DQMH in tests and what are the main advantages of using the DQMH at first. And then we'll try to go more deeply into the DQMH testing with the DQMH modules with testing. And we'll see standard practices, what is recommended, and see how we can use some modules and settings to fit with a sequential process model and the batch or parallel process model. Then we'll try to summarize all that with few pros and cons slides. Maybe it will be where you will have most of your questions. So don't hesitate there in the pros and cons, maybe to add some things that I may have missed. And at the end, I will do a quick presentation of a tool that we wrote internally at Neosoft Technologies to try to fix all the counts that we will describe here and see if there are some things that we can do to automate some of the action to prepare the DQMH module to be used into testing. But first of all, I will present here Samantha John. Samantha John is 35 years old. So she almost has the same age as me. I'm a little bit older, but will not spend too much time on that. She studied engineering at Columbia University, and she found hard actually to be a female in our world. So she was always considered as a beginner, and at the end, she was getting used to be one of the few women in the room. So at the age of 26, so 10 years ago, she co-founded Upscotch to combat gender gap in programming to allow kids to learn coding. So what is Upscotch? Actually, Upscotch is the first programming language designed for touchscreen devices. Actually, you can download and install Upscotch from the Apple Store. And as you can see, it's a visual programming language, and it can you can actually build games or a few applications with Hopscotch. So it's really tailored for kids to let them learn how to code things and how easy it can be to actually code things. So Hopscotch has been downloaded more than 24 million times, and more than 36 million of games were developed using Hopscotch, which is pretty amazing. So all that to say that Simon Tejam actually is trying here to break the gender gap in programming and help kids to take a look at programming wherever they are, and so it should look familiar for a bunch of us. Let's dive into a quick introduction to TestStand. So actually, I want to really make the distinction that TestStand is an engine. So it can run test sequences, can do more than that, but it's really an engine that allows running sequences and execute steps. We often say that TestStand is the UI, it's the sequence editor that is shipped when you when you install TestStand on your computer. But actually, the sequence editor is just a UI on top of the TestStand engine. So that's it. And there are a few concepts here about TestStand. So we are using adapters. Adapters let us call specific specific part of code written in some languages. So you've got adapter for LabVIEW VIs, for example, C++, DLL, .NET Assemblies, ActiveX, now Python, since few release. You have some steps for flow control, like if else, switch case, etc. You can call subsequences. Subsequences are sequences within the same sequence file or in another sequence file. There is a module for database handling, so you can publish some data and results into databases. You've got synchronization steps and IVI and switch executive native support. So a few functions are delivered with TestStand and are accessible from the sequence editor. The purpose of TestStand actually is to execute scripted sequences. When I say scripted, it's because we have to write them before execution, and when they are executed steps after steps. So there is no exactly compilation. It's more like on-time execution. And I like this concept here is to say that when I want to program sequence file, I must determine when a code needs to be executed. If I can define the when, it will tell me where I need to add the code in my sequences, and actually it can be in the main sequence or it can be in sequence callbacks. For example, sequence file load, pre-UT, post-UT, etc., etc. So when I determine when a step should be executed, it will tell me where the code has to be inserted. And natively with TestStand, I can handle testing one UT or multiple UTs. So by default, you've got two process models to handle multiple UT at a time, batch model or parallel model. And according to the number of sockets you have, TestStand will actually duplicate in memory the sequences for each of the units to test. So this is a quick intro for TestStand. Now we will dive into traditional TestStand programming. So how we use TestStand when you are not using DQMH within TestStand. So actually each step that we have in the sequence and all the logic. So we try to create very atomic steps, very small, and the steps actually execute the code. And when the steps finishes the code execution, it goes back to TestStand, and TestStand goes to the next step. So we try to make steps short in time. We try to keep them really, really atomic and small, because when an adapter runs, TestStand actually waits until it returns, so until the code within the steps stops executing. And usually we handle termination within the steps. So we can see in the example here, I've got some DQMH task, but while the DQMH task is running, I'm also monitoring the execution. And if an operator decides to stop the sequence, my step must handle this situation and stop its own execution, because actually the engine is waiting for the step to stop. So the step has to stop itself. And we can also, a step may produce errors. So we see that we've got the error out here. So if you have a VI with an error out, actually when you use that VI as a step in TestStand, you will have the error being directly mapped onto the step .result.error container. And actually the engine will monitor that to trigger the error callback in case you've added it into your test sequence. So a step may be able to produce errors that you will trap or within the step itself or within TestStand into the sequence. And the step may produce data. So here we've got a voltage value that we want to maybe return to the sequence, and TestStand may collect that data for result processing or reporting. So that's the basics of what is TestStand and how we use it usually. Here it's an example with LabVIEW. Now, the question is, why would I want to use DQMH with TestStand actually? One of the main reasons that comes to my mind is that I can code a module for most of you know DQMH. So I can create the module, and when I create the module, I define my requests and my broadcast, and a tester will be updated and scripted based on the request I built. So I can just, without TestStand in mind, create all the requests for my module and actually have a tester to test it, and I can manually play the role of TestStand, if I can say it like this, and trigger the requests from the tester. So here I can create a module without even thinking about testing. Also, that tester, which is accessible from LabVIEW, we'll see after that we can access it from TestStand itself. So when I will begin to run my sequence, I will be able to use a tester and see what's going on. If I've created enough broadcasts in my module, for my module, I will be able to capture that broadcast into my tester and actually have like a log or a debug view ready to use from TestStand. Also, one thing which is really, really important, I talked about it in the previous slide. In TestStand, we try to make the step as small as possible. We try to make them atomic. By default, the DQMH makes you think about the API, and so you have to create requests with inputs, and if you chose to create a round trip or a request and reply, you have to think also about the output and the time it takes to get it. So because you have timeout in your module, so you have to create by default atomic code, and that atomic code is accessible from the requests you create. So that's really interesting here. And actually, because the module, the main VI of a module runs in parallel to the sequence execution. So we will see that we start a module, the main runs parallel of the sequence execution. You can actually keep a context into your module. So you can keep collecting data and you can have your sequence executing and you can keep collecting data inside the module. You have like a local context into the module. So that's very interesting. For example, if you want to do continuous monitoring, for example, or if you have a communication protocol that you want to handle, CAN, for example, you can just collect all the data that's coming to your port and save it into a file, for example, without really thinking about that into your sequence. So you can, by default, have that with DQMH. So all that are reasons maybe that will lead into using DQMH with TestStand. So this will lead into applying some standard practices when using DQMH with TestStand. We must think about launching the modules and stopping the modules from TestStand. Lately, we helped a company who wanted to do something else, actually. They wanted to have their UI that we would launch all the modules necessary just to get, for example, a manual HMI just to be able to trigger some requests, etc. But also use the requests from the sequences. So they wanted to start the modules from the UI and then only use the request into the sequences. That's feasible. I don't like it much because it couples the sequence to the UI. So my standard practice here, or my advice here, would be let TestStand in charge of launching and stopping the modules. You will have to think about that, and we will see that in the pros and cons. You really have to think of when you need to launch and when you need to stop a module, actually. Also, so the module's core, the main VI, will handle the logic, actually. So all your code will be within the main VI, and you will only use the requests into your sequences. And most of the time, I advise to use round-trip requests when using DQMH with TestStand. Round-trip is not often used with DQMH, but here it has a big advantage is that the round-trip actually will broadcast every replies that a request may produce from the main VI. So when you will launch a tester from TestStand, that debug window that you will get using the tester will actually display all the broadcasts coming from all the requests that you will do into your sequence. So that's pretty nice because just designing all your requests as round trips, you've got that broadcast that is scripted for you automatically and that streams the internal data from the main VI to the tester. So it's pretty nice for that, and it accelerates development. So now we can just maybe dive into the usage of DQMH from your sequences. So if you want to test a single UT, there is a great chance, or 99% of the time, you will use a sequential process model. I will refer to the sequential process model as SPM into the future slides. And into the sequential process model, there is a high probability that you will only use singleton modules. You've got one test socket, and that test socket will need to launch all the module it needs to perform the test required or scripted into the sequence, and it will stop them when done. So there will often you will often need only singletons. Maybe, and I'm sure that some of you use already clonable modules into TestStand, but maybe it's in case of controlling several instruments of the same type. That's also maybe a usage of clonable modules into sequential process model, but definitely most of the time you will use singleton modules. When you install DQMH from VIPM, you maybe notice that there are some DQMH TestStand examples that are shipped with it, and there is that TestStand thermal chamber control examples that is shipped. You can, if you analyze the sequence from the example, you can see that modules are launched and stopped within the sequence, within the main sequence, actually. I would not advise to do this because you will need to start and stop actually the module every time you test a new UT. So it will take time. You will need to initialize and dispose resources each time you test a UT. Maybe there is something else to do that is a little bit more clever. And that will be to use actually callbacks. So you've got several callbacks that you can use to do this. Actually, that there is a pre-UT loop or process setup callback. It depends where you add your start and stop request. And but this will start and stop your module once for all the UTs that you have to test, and it will stop the module at the end of the UT's test. So it's pretty efficient. You will launch your module once, and you will kill it only once, and you will use it across your UTs, just sending requests. If you need to actually launch or decide which module to launch according to the UT identification, maybe you will need to fall back into the pre-UT callback. So if we look a little bit at TestStand, so I guess you see TestStand here. It's TestStand 2021. So it's all white. I just modified a little bit here the colors to be gray because it kills my eyes. I'm an old guy. I started with TestStand 4. I'm still not used to use TestStand here with the latest flavors where everything is white. So I've got a little bit of gray here. So what I was trying to illustrate here is that maybe you can just start the modules into the pre-UT loop. Here it's just a sequence callback that I've added. Pre-UT loop plus UT loop here from the model callback here. And you can just start the module. You just sync it. Don't forget to sync it. So 2 steps actually to start a module. Then I've got my main sequence, and I can do things here. I can just send requests. I won't advise for this. Or I can perform some requests and reply. I like to have a reply. Even if my reply is just no error, I like to have a reply in my TestStand sequences. And if I have done my job well, this one is actually a run trip. And so doing this, I will just run my module only once. And I will do something. It will return. And this test sequence passed. And actually, if I go into my singleton here, it's still running. Okay, it's not stopped. So I can continue testing UTs. It won't be stopped yet. If I stop here, it will be stopped, actually. And if I need to actually launch a different module according to the serial number of my UT, this is where I fall back into pre-UT and post-UT. So actually, it will be run each time I start a new UT. So I won't have a major gain here, but what I can do here is capture actually the UT serial number. Here I've got a basic regex regular expression. If it starts with A, I can start this module. Otherwise, I can start this other module. So this is basically how you can filter and decide after identifying your UT which module to launch. Yes.
One common question is, Claude will recommend to launch and start DQMH modules from TestStand plugins. Do you have any comments? Or?
You can. You can definitely. It's not a problem. The advantage of plugins is that it's you can just remove them or uninstall them pretty easily. But if you have a very well identified test station with a sequence that do not need any plugins and that you have in control, I don't see actually the exact advantage of using a plugin versus using your sequence callbacks. One advantage of plugins is that you can still use the default process model and just personalize that execution from the plugin itself. But here, the callbacks are just from my sequence. So actually, my sequence will force a specific behavior of the process model without modifying the sequential model.sec that we see here. But definitely, it's a great tip. Yeah. So if we're going back here,
what are the pros and cons of starting modules in pre-UT loop and in the main sequence?
The advantage of using the pre-UT loop is that this callback runs only once before starting testing the UT. So I start only once my module, and let's say I've got 10 UTs in a row to test. I do not stop and start 10 times my module, but I only started once and I stop it once. And in the middle, I can test my 10 modules one after the other. So the load times are a little bit faster.
So it's more about what you'd like to do.
When and where you there is no bad way to do things, but there are some more efficient ways to do it. If you want to use multiple UTs, so you've got basically two options in TestStand, using the batch and or the parallel process model. Here you will have a high probability of using a mix of singletons and clonable modules from into your test sequences. It doesn't change much, actually, using a singleton and clonable module. With a clonable, we'll see that there are some challenges, actually, that will come with it, just to address the good clone. So, again, we've got the same problem into the DQMH TestStand. TestStand example. Everything is loaded from the sequence. It requires synchronization from or within the main sequence. This is an example again, and I'm not criticizing what is shipped as an example. Again, just an example, but there are some more efficient way to do things. If your module is quite big, it can take times to launch. So maybe thinking about launching it only once and stepping it only once could be a great idea. So same idea applies actually. We can use the callbacks from the batch and parallel process models. Actually, most are identical to the sequence process model, but you maybe want to go into pre-batch for launching modules actually. So it will maybe be a different callback, but again, thinking about when you should launch a module and stop the module will lead into where you have to add that start and stop request for your module. What we've seen actually is that most of the times the clonables that we are using are linked to the test socket. So I've got one test socket per UT, and I will duplicate my clonable module to address that UT as many test sockets is running into my test sequence. So if I've got 4 test sockets, so I've got 4 in my batch, I've got 4 times the same sequence that will be duplicated and run into memory, and I will maybe want 4 modules to be executed. So I will have my clonable launching 4 clones. And here comes the problem of how do I synchronize my clonable to my test sequence, actually? Which module ID should I target? Here, if I go back to TestStand and I go with a batch sequence, what I've done actually here, I've got a pre-UT, post-UT, I've got main sequence of just doing something, whatever it is. It's just, oh, I see. Why is that? No, it's not the good one. I've closed. Yes. Here I just can see that this is a clonable module here, and my module ID, just to retain it, because I'm into the same file again, just for the example, I'm using a file global here to retain my module ID. So I start my module. This will start into the pre-UT loop, actually, and I will sync. And in the post-UT loop, I will stop. And within the main sequence, I will just ask the module to do something. And it will reply with a value. And I will just create a pop-up. And here it's a batch model that I will use. And if I execute this, one thing that is interesting, it's not always the same results each time. I'm just not identifying the modules here. I will say go. But I can see here that my socket 0 actually has socket module ID 3, and my socket 1 has module ID 2, socket 2 1, and socket 3 4. So, and if I run again the sequence, there is a high chance that socket 0 will even have another socket module ID. So it begins to be difficult here to retain which socket is using which module ID for my clonable module. So I can still use a file global to do this, but file global is not really a good solution here. If my sequence is actually made of several sequence calling subsequences into different sequence files, I will have a problem accessing the file globals. There are some options to share the file global through several files, but it leads into some weird settings of TestStand. So you must think maybe about using something else. One thing that can be done, and I've seen that working with Chris Farmer. Chris Farmer is working for Wiredin in Australia. We've worked together on a project, and they had a controller actually, which is, if I remember well, it's a singleton, and every clonable module could broadcast their data to that singleton, and that singleton was centralizing things. So like a controller, but maybe there is something a little bit that we can do to ease that. It will require, however, if I stop my execution and close this, if you know how DQMH work, and if you've been curious enough to open a start module, you may have noticed that the module ID actually come from a feedback node. So it's a local memory that just keep incrementing the last module ID to identify the next clone that it will launch. So actually, if we modify just slightly the module, and give the responsibility to TestStand to give the module ID I want, it gives something like this, where I can link my module ID, which is the input, supplementary input that I've created. My module ID, I link into the test socket, my index that I can have from every sequence that is running or into a specific socket. +1. Why +1? Because my index starts at 0, and when you use clonable modules, 0 is when you use your clonable as a singleton. So if you use run test socket, my index +1, you can have actually your sequence do something and always target the same expression here, whatever the sequence use. And here I've created, if I go back into the pre-UT, just as a scope, as a probe, the actual module ID, I've kept it into a file global. And if I launch this, go. I can see here that my socket 0 has module ID 1, socket 1 module ID 2, socket 2 module ID 3, so my index +1, and socket 3 module ID 4. So now my module ID is in line with the test socket, actually. So it's a little modification, and it will keep my module ID in line with the test socket, which is very easy then to use to send the correct request to the correct module ID without having to retain anything. Is there any question about that yet?
Or it's pretty neat.
Pretty neat. Okay.
That's your mustache.
That's my mustache. So here it demonstrates that you can use the test socket at my index actually to link a socket to a specific clone that TestStand will launch for your UT. Actually, that will lead to the pros and cons of using the DQMH with TestStand. We've seen that launching a module is quite easy. 2 steps. I've got a start and a sync. I can use a basic Boolean local just to get that sync value to be shared between my two steps. So very easy. We can access all the default requests that come with the module. Show hide panel diagram. I can stop my module from there, etc. So that's pretty cool. Also, I can, as I said before, I can use my testers, and I will come back to that a little bit later, from my sequence to actually capture all the broadcasts. If the requests are round trips, it's even easier to actually capture all the broadcasts that will be generated from the sequence. So it's a great help for debugging and manually controlling instruments. For example, like I still have my tester under my hand, and I can just interact with it. Be careful with the tester, and we will come back to that in the cons. You have to think about when and how you start the tester, because a tester is actually blocking. So when you enter a tester, it's a while loop. So you can only exit the tester by stopping it. So we'll talk about that a little bit later. Yeah.
Quick question. Ever had any problem with orphan clonables?
Orphan clonables. If the modules are well linked to your test sockets and you've been clever into placing your stop module requests into your test sequence, you should not have that problem. I faced that problem when my stop module was not placed at the most clever place, actually. And if I just forgot a module ID, or before fixing that issue that I showed earlier, linking the test sockets to the module ID, my dictionaries. I was using dictionaries, and this one was not perfect. And yes, I had orphans clones at that time. But other than that, no problems really.
Any ideas how you can monitor if you have any orphans, or I mean, it's just
testers. The tester actually can list all the clonable modules are still running. Be careful though with TestStand. TestStand is keeping in memory all the resources that you've used into your sequence. So if you're debugging with a sequence editor and you want to you finish running your sequence, so you want to go back to your module, you might see the module library to be locked, because actually TestStand still has the hand on it. So you must unload the modules first. So maybe one may think that a clonable module is still running, but in reality it's not, and it's only TestStand keeping the end on the module library. But I can show that right after.
And Claude says always put your stop request in your cleanup section. I guess it depends where your start is. Or...
Yeah, no, for always put it into the cleanup section. Whatever happens, the cleanup section will be executed. So your stop module should be into your cleanup section. If we go here and we open a sequence with tester, and here we can see that I still start my UT, I sync it, and I've got a local here, tester visible, so I can change it. It's set to true, so I can go here. And we can see here that my tester is actually launched thanks to another VI. If I open that, we can see that I've got specific code here just to launch a tester in parallel to the sequence and without blocking the sequence. You're not obliged to do a VI like I did. You can just use a new thread, but think about killing the thread or waiting for the thread to end at the end of your sequence, or whenever it's necessary here, just use a VI and a VI server to launch the execution in parallel. And if I actually run this sequence, we can see here that I've got a tester that is running and is able to capture any broadcast, because here's do something else is a request and reply, and it broadcasted what it did. So, oops, here it is. So I've got the same number that's run did here, but so I can have tester here and try to do something else. So I can still have that tester that is active and my sequence running in parallel. So that's pretty nice. Here's testing the sequence passed. I can stop it, and I can see that my module is not running anymore. So the tester is still running in the background and still monitoring the module execution. And I must think manually of stopping the tester. And here, if I want to actually close it, I must unload the module. And now I've got the end on it, and I can close it actually correctly. If I want to close the tester from TestStand, I will have to think about it also. I try to accelerate a little bit. Other pros, steps in the sequence are lightweight. Yes, we use in TestStand, standard TestStand programming, the steps actually contains the code. Here it's not true. The step actually is only the request. So the code is quite lightweight. It helps preloading a sequence a little bit faster because your sequence file will be a little bit lightweight. So that's pretty cool. We can remember that clones fit well with parallel testing, where each sequence should have their own resources. So we can think about one clone equal one socket rule of thumb, but that's a good idea. And single DOM fit well with both single socket or parallel testing, and where we should share the same resource. The counts. So you must think about stopping the module. As I said, if I do not stop correctly the module, it will continue running into the background. And it can be actually a problem. It can continue executing even if it should not. So be careful with that. You really have to think about stopping the module. The actual running code is running in parallel of the sequence. So natively, it's not possible to stop or resume a code that is waiting for a request to come back. Okay. In TestStand, if you launch a thread in parallel, you can just pause the execution and it can pause everything. Here, since the code is running into the module in parallel of it, natively you cannot just monitor the TestStand execution. You must think about adding the TestStand monitoring into your steps. So you will need to modify the code actually. To add the TestStand monitoring options into the code. If you've started your requests as a request and reply, and you finally find out that you should, or just a request, and you should modify it to a round trip, you can do it from TestStand. There is a scripter that can that allows you to change from one event to another, one kind of event to another. Be careful doing this. It will change the prototype of the step of the request actually, and TestStand doesn't like it much. So you might fall into the trick of having to manually refresh every single call to that step. And if you have 500 sequences, each with 500 steps, can be a long action to do this. And again, this is a prose, but it's also accounts. The action is not in the step. So before in standard TestStand programming, you could just add a breakpoint and dive into the LabVIEW code, for example, or any kind of code, and add breakpoints, probes, and see what was going on. Here, it's a little bit more difficult because the action is a request. So you have to know exactly where in the main VI your request will be treated into the MHL. And you have to put your probes accordingly and your breakpoints accordingly. So you've got some more actions to perform to debug your module within the sequence.
Yep. One question for Martin. How do you react on broadcasts? TestStand doesn't handle LabVIEW events.
No, but your tester can, and every module that is running in parallel can listen to the broadcast of other modules. So you can actually send a broadcast from a VI and capture it from another VI. So I was speaking earlier about a controller. You can create a controller module that would be maybe a singleton listening to every broadcast that any other module can execute and captures data from there and then send some other requests. If you look at the TestStand example, which are shipped with the DQMH installation, you've got one controller module that is in charge of monitoring the TestStand execution. So that's a way to do it. And so when the monitoring, the stop occurs, this VI can act on the other VIs, asking the other modules to stop, for example.
So basically not from TestStand.
Not from TestStand itself.
Within
LabVIEW code. Yeah, you have to, yeah. So it's a little bit, yeah, you have to think about it. Launching a tester is natively a blocking action. So I showed you earlier, I need some additional code to launch the tester in parallel to my sequence. I cannot just drop the tester VI into my sequence because it will block the execution. So you have to add some more code to do this. And in the same way I was speaking earlier, if you need to monitor the sequence execution, and the main module is doing something, you've got an action which is performed and which is very slow in the MHL. For example, you've launched an acquisition, that acquisition is 30 seconds long, and you need to stop the sequence right now. actually your request and reply will wait for the reply and won't get the notifier answer until that 30 seconds are over. So you really need some sort of monitoring to stop the execution. Otherwise, you will have to wait until the request is done to really stop the test and execution. So this can lead into frustration if you have very slow actions that needs to be performed into your module. And also error handling. Error handling must be done in several places. So you've got to handle it into the module core because the DQMH just traps the error. You've got default behavior into the DQMH module, but maybe you will need to also deal with it into TestStand thanks to error callbacks. So you will have to now to duplicate your effort to treat your errors. Most of the time, I try to do nothing into the module, dedicate the error handling to TestStand thanks to an error callback, and I treat it from here. So the TestStand callback captures the code, the error code, and thanks to the error code, I do something. I do nothing, or I can retry, I can whatever, but all the error handling is dedicated to TestStand. And maybe I can show you something that we've been working on lately at Neosoft Technologies. We've built a tool actually to try to modify or test-standify a DQMH module. The idea here is to have DQMH modules that you've created in LabVIEW without thinking at all about TestStand and modifying it to use it into TestStand later without modifying the original source code. So you would still have your module running in LabVIEW without any modification, and then we will just duplicate that and adapt the module to be used in TestStand. And the idea is to here create a source distribution from your module, modify the request to add termination monitoring. We'll do a couple of things with the tester, create a pack library, create a module launcher, create a sequence file, create a sequence call for all the requests, and maps VI IOs to parameters. So the idea is only to use sequence call to target the DQMH module. So here I'm going back to another virtual machine just to show you how it works. Here I've got a module, test module project here that contains one clonable module and one singleton. And I will try to test-standify them. So this singleton, I just don't want to put them into memory. I will show you after the code, but before the demo. The idea is to be able to test-standify the module. So if I run that, so we've made the test-standifier as the DQMH module itself, but I can click here. We'll read into the project and try to list all the modules we have. Here we'll just start with a singleton module, and we'll click test-standify. So here we are automatically building a source distribution. With this can take time. The idea is to create a source distribution from the module, so we can create then a pack libraries that contain everything the module need, even VI from the VI lib if you've got some OpenG VI, for example, into your module. Then when done, we modify the copied module to insert the tester into the library. We create a launcher for that tester, and we search for all the requests and reply that are linked to that module. And we modify them in order to insert the termination monitoring into the request and reply. The idea is to stop waiting for a reply if the monitoring says that we should stop the test and execution. Then we build a pack library from it. We connect to TestStand. We build a sequence file on top of it. And here we are ready to rock. So we've got an output folder. The output folder looks like this. Everything. So here it's actually the source distribution that has been created with the DQMH modules and all the VIs that we're using, so the VI lib, etc. And it creates that pack library and creates also that sequence. And if we open that sequence, here takes a little bit of time. Yeah, here it is. Go. we can see that we've got that sequence that has been created from scratch. We inserted that post-step runtime error callback. That the start module is here. It's actually only one VI. So earlier I showed that you needed two VIs to start a module here automatically by scripting. We created two VIs. So the start and sync is already scripted and linked. And we can see here that you've got that launch tester that is made automatically also. If we take a look at it rapidly, it's all scripted. So we create all that code by scripting to launch the tester automatically. And everything is mapped to parameters. So that input show front panel has been copied actually into the parameters with accurate default values and we linked that parameter variable to the input of the VI. And here I've got my request and reply example. Also, all the inputs have been created into parameters with default value, which is correct. Everything in the parameters is all set by value or by reference if it's an input or an output. And if we look a little bit rapidly at the code, we can see here that we inserted the sequence monitoring from here automatically. And that timeout, that module timeout that we have actually enters into that VI that has been scripted as well. And this VI creates arrays of 100 milliseconds timeouts. So if I've got a general timeout of 5,000 milliseconds, here it will create 50 100 milliseconds values into that array. And so I will have a global timeout of 5,000 milliseconds by steps of 100 milliseconds. And if I want to stop the execution, it will stop within that 100 milliseconds. And all that is done automatically. And you've got actually into the output everything that is ready to run packed into a pack library here. So with these two VIs, with these two items, you are ready to rock. And if you want to launch a new sequence file, you just have to add a sequence call and go get that sequence file. Here, don't do this, it's just for the demo. And I can have my launch tester, for example, and I can just link or use the default value, which is true, or link whatever I want here. So it's pretty easy to create the sequence, only sequence call, no more calling of the sequence of the DQMH module itself, and everything is scripted. If your module changes, like it's been made out of a copy, you just have to rerun the wizard and it will recreate everything for you. And that's it. It's the end of the demonstration.
Claude asked if you're going to share the scripting tool.
That's a great question. We still have to think about it. We've used it into several projects with numerous modules and with numerous requests. It really helps. It's reducing the development time by several hours because if you have to create that automatically and remap everything, so it can take several hours. Maybe yes, it will be up to Vincent. I don't know yet.
It might be up to you. You put the time in. I guess there's 1 minute left until the next session. But yeah, if there's any questions, I guess they can also reach out to you afterwards.
Yes.
Thanks, Benjamin. Thanks, Mathieu.
So I had to speed up a little at the end just to be on time. If you want to share more data, or if you want to speak about a project or any advantages or caveats that you've been facing using the DQMH with TestStand, do not hesitate to reach me out. I will be online for 1 or 2 more hours, so do not hesitate.
I guess people that want to leave can just leave, but maybe as an example, what type of you gave some ideas of what you would use DQMH and TestStand. you have a concrete example that you can give in terms of past projects you've done? Or?
Past project, we've done something with scan, for example, just capturing data. All the data that was entering on the port need to be saved into a file. So that was dedicated to a module with an helper loop just doing this. And when we had some values, interesting values into the sequences, it was just a request, hey, give me the last value of that signal, and that singleton could answer back to the sequence. So it was pretty easy. We've used it also for HTTP requests to an MES, for example. So all the requests for the MES of declaring a UT, for example, declaring the status, etc., everything was done into very simple API, and all the core was handled into the main VI, and the main VI was in charge of doing the HTTP requests, linking the MES to the sequence, actually.
And I guess for this one, the main advantage was being able to be within the tester while running the test sequence, because that was an afterthought. Basically, that was an added feature once the system was already deployed.
Yeah, it's been already deployed. So this one specifically was made as a plugin, but the access to the MES was quite difficult to have. So it was faster maybe to test it with a tester directly from LabVIEW. So we started with LabVIEW, doing all the things manually with the tester just to ensure that all the HTTP requests were correct. And when everything were correct and tested manually, it was quite easy to add it into the sequence and to get it ready to run on the test station.
Yeah, minimize the production downtime.
Yeah.
When doing the update. Okay.
Here we are.
That's it. You gotta share your link for the Movember movement.
So that for people who know me, I'm wearing a mustache and usually I'm not, but I'm supporting Movember. So if you go on my LinkedIn profile, you can see that and you can support if you want.
Well, I gotta say, why Movember?
But you can answer maybe because you are part of the Movember team.
Yeah, I'm walking.
But you can support Neosoft team into the Movember movement. And if you don't know the Movember movement, I encourage you to just Google it, and you will get a better explanation that what I can get or what I can give here.
Okay.
Yeah, well, thank you very much, everyone.
Thank you. Thanks, Ed.
Bye.